Hey everyone, welcome back to Lab 5. Please be sure that you've completed the Angular Kinetics lecture and practice problems prior to completing this lab, particularly the computing the center of gravity problem. It gives a great overview of what we're doing today. Today, we're going to look at center of mass of individual segments and then center of mass of the sum of segments, so a whole person with and without a box. So you're going to be asked to do that. So in question 1 here, you see you're asked to compute the position of the center of mass of the leg segment. So you're going to compute the center of mass of one segment. And then for question 2 here, you're summing the center of mass of all of the segments relative to the masses themselves. And then in question 3, you're doing the same, but you're also including the box that you see in the video. And then questions 4 and 5 are a bit more conceptual, so about factors that influence the position of center of mass and adjustment and techniques for posture. And then questions 6 through 8 relate to torques or moments created on the spine from the box and other segments, so you're asked to compute the moment arm of the load, the total flexor moment or the torque, and forces that are needed to generate in order to maintain posture. These will require a little bit of computation, but you have all of the necessary information because you pulled those X and Y coordinates from your tracker files and pasted them into Excel. And then questions 9 and 10 are a bit more conceptual again, and they're also related to posture techniques and moment arm and torque. Okay, so I'm just going to refer back to question 1 here because this is going to be the part that I walk you through. We are asked to compute the leg segment center of mass. So we're going to have to use those segment center of mass equations that you used on the practice problem in Angular Kinetics for computing center of mass. But they're also listed in your lab document if you scroll up, computing overall center of mass. So again, the steps are for question 1, and then as it relates into question 2, computing the individual segment center of masses. So this is the equation that we're going to use for the x coordinate and then for the y coordinate here. So in these equations, as you notice, we have x, so that's going to be our resultant x coordinate equals xp, where p here stands for proximal. So proximal as it relates to anatomical position. So in the case of the leg and foot segment, our hip is going to be our proximal. So that will be our hip x coordinate plus p, where p is the percentage of the center of mass from the proximal joint expressed as a fraction, which we are told right here. So for example, if the center of mass is 50% from the proximal joint, p is equal to 0.5. So you can actually scroll down to the table here, and it has the segment. So for example, the leg and foot segment, the center of mass location from the proximal joint is 60%. So as a fraction, that would be p equals 0.6. Okay, I'm going to scroll back up here. So we know what p stands for, and then xd is just our x coordinate of our distal. So our distal, again, in the event of the leg and foot segment, is going to be our ankle x coordinate, and then minus xp, which is again the proximal x coordinate, which is our hip in the example of the leg and foot. And then we'll do the same thing for the y, where again p is proximal and d is distal, and then this large p here is that percentage expressed as a fraction. I'm also going to take a look at these equations here. So for question 1, we're asked for just one individual segment, but for questions 2 and 3, you're asked to compute the overall center of mass of the person and then the person with the box. So this is going to be useful because this is going to be the x center of gravity or center of mass coordinate of the sum of the individual mass and x coordinates multiplied. So this would be, for example, the leg and foot segment mass times the leg and foot segment center of mass x coordinate plus the head and trunk mass and the head and trunk x coordinate product, plus, again, the mass of the arm and hand times the arm and hand x coordinate. Summing those divided by the sum of all of the masses. So in the event of the person, it would be the arm and hand segment plus the head and trunk segment plus the leg and foot segment, which is the total mass of the person, which is 70 kilograms. And we're going to do the same thing for the x and y coordinates. And then when we have to add in the box, please just note the mass of the box is given to us at 10 kilograms. Okay. So we are going to get coordinates here, essentially, for both of these. So whether it's just the segment center of mass, it's going to be an xy coordinate. So you would just open parenthesis, x coordinate, comma, y coordinate, close parenthesis for these answers. So also when you're computing the overall center of mass. Okay. So let's start with computing the foot and leg segment center of mass in Excel. So I'm going to minimize here. I've set up my Excel document like this. So again, this is just pulled right from Tracker. So I have my time, my X and my Y coordinate for the ankle at frame 206, and my X and my Y for my hip, my shoulder, the wrist, and the box, all at frame 206. Remember, we just have those individual data points there. I also included in my Excel the individual formulas for the X and Y coordinates for finding the individual segment center of masses. So we're going to use these formulas. And then I also just recreated the table that was listed in our lab document. So I have my listing of my proximal and distal locations for each segment. So hip is proximal, ankle is distal, shoulder is proximal, hip is distal, and so on. And then I have my segment mass percentage of body weight, which I will be using later when I have to compute my overall center of mass. And then I have the center of mass, that p-value that we talked about and related to these equations. So my 60% is 0.6, 34% is 0.34, and so on. Okay. So let's use our equation. So I am going to work down here for question 1. So I'm finding the center of mass of the leg and foot segment, so the x coordinate. So I'm going to do x is going to be equal to my x proximal, so that's my hip x coordinate, plus we're going to do open parenthesis, my p-value, which we know is 0.6 for the leg and foot segment, times the difference between the x distal, so that is my ankle x coordinate, and the x proximal. Good. I'm going to press enter, and I get my x coordinate value there. I'm going to do the same thing for the y. So my y is going to be equal to my y proximal. So proximal for the leg and foot is the hip. Perfect. And I'm going to add open parenthesis my p-value, which is that 0.6 or 60%, times the difference between my distal y value and my proximal y value. And press enter. Oop, I forgot a parenthesis. So yes, I will accept that correction. And I have that computed. So we've actually answered question 1 here. We have our x and y coordinates for the center of mass of the leg and foot segment. So I'm going to just scroll down here again just to reflect on our questions. So number 1, we did it. We computed the position of the center of mass of the leg segment. You're going to have to do that for the head and trunk segment and the arm and hand segment as well. And then use that second equation summing the product of the mass and center of mass locations for each of those segments. And then you're going to have to do the same thing, but you're also going to have to include the box. So questions 1 through 3 are all computation as it relates to center of mass, just using those same formula. And then again, as a review, 4 and 5 are a bit more conceptual. And 6 through 8, again, is where we're going to do a bit more computation, but as it relates to moment arms and total flexor moment or torque, and the forces needed in order to maintain posture. And then again, 9 and 10 are just some more conceptual questions as they relate to moment arms and posture techniques. That is it for this lab. If you have any questions, please post them on the discussion forum, email us, or ask us during office hours. And as a reminder, you will be asked to submit your tracker file, so your box lift and associated calibration file, the Excel spreadsheet where you're going to do your computations, and then of course your final lab assignment with your answer table and work table using the template on D2L.